Answer each of the following questions. In part A, what is the y-intercept of f of x equals a times b to the x minus 4? At the y-intercept, x equals 0. Plug in 0 for x and determine the result. Plug in 0 for x. This gives us a times b to the negative 4 on the right side. This becomes a over b to the 4. The y-intercept is 0, a over b to the 4. Now we'll move on to part B. The point negative 1, 5 over 3 exists on the graph of y equals a times 5 to the x. What is the value of a? We can determine the a value by plugging in negative 1, 5 over 3 and solving for a. Rewrite y equals a times 5 to the x. Plug in the point negative 1, 5 over 3. Five to the power of negative 1 equals 1 over 5. Cross multiply. The value of a is 25 over 3. Now we'll move on to part C. If the graph of y equals 1 over 3 to the power of x is stretched vertically so it passes through the point 2, 1 over 12, what is the equation of the transformed graph? The general form of a vertical stretch is y equals a times f of x. Replace f of x with 1 over 3 to the power of x. Plug in the point 2, 1 over 12. This gives us 1 over 12 equals a over 9. Cross multiply to get 9 equals 12a. Divide both sides by 12 and reduce to get a equals 3 over 4. The transformed graph is y equals 3 over 4 times 1 over 3 to the power of x. Now we'll move on to part D. If the graph of y equals 2 to the power of x is translated vertically so it passes through the point 3, 5, what is the equation of the transformed graph? The general form of a vertical translation is y equals f of x plus k. Replace f of x with 2 to the x. Plug in the point 3, 5. Two cubed equals 8. Subtract to get k equals negative 3. The transformed graph is y equals 2 to the x minus 3. Now we'll move on to part E. If the graph of y equals 3 to the x is vertically stretched by a scale factor of 9, can this be written as a horizontal translation? The general form of a vertical stretch is y equals a times f of x. Replace a with 9 and replace f of x with 3 to the x. Get a common base. Multiply the powers and add the exponents to get 3 to the x plus 2. If the graph is stretched vertically by a scale factor of 9, this is equivalent to a horizontal translation 2 units left. Now we'll move on to part F. Show algebraically that each pair of graphs are identical. In part 1, show that y equals 25 times 5 to the x and y equals 5 to the x plus 2 are equivalent. Rewrite 25 as 5 squared. Multiply the powers by adding the exponents. This gives us 5 to the x plus 2, which is the same as the second function. In part 2, show that y equals 1 over 8 times 2 to the x and y equals 2 to the x minus 3 are equivalent. Rewrite 8 as 2 cubed. Divide the powers by subtracting the exponents. This gives us 2 to the x minus 3, which is the same as the second function. In part 3, show that y equals 2 to the negative x and y equals 1/2 to the x are equivalent. Rewrite 2 to the negative x as 2 to the negative 1 raised to the power of x. Two to the power of negative 1 equals 1/2, so we get y equals 1/2 to the x, which is the same as the second function. In part 4, show that y equals 64 over 27 times 3 over 4 to the negative x, and y equals 4 over 3 to the x plus 3 are equivalent. Three over 4 to the negative x equals 4 over 3 to the x. Rewrite 64 over 27 as 4 over 3 cubed. Multiply the powers by adding the exponents. This gives us 4 over 3 to the x plus 3, which is the same as the second function. In part 5, show that y equals 3 over 4 times 1/3 to the power of x, and y equals 1 over 4 times 1/3 to the power of x minus 1 are equivalent. Separate the fraction 3 over 4 to 1 over 4 times 3. Rewrite 3 as 1 over 3 to the power of negative 1. Multiply the powers by adding the exponents. This gives us 1 over 4 times 1/3 to the power of negative 1 plus x. Reorder the exponents so x comes first. This gives us 1 over 4 times 1/3 raised to the power of x minus 1, which is the same as the second function.